Welcome to another episode of Solving ROS2 Problems. We have compiled 4 different problems of different nature, robot building and motion planning of Moveit2 as well. The first issue is launching any other world of Turtlebot 3. This guy contacted me privately as well, where he explained that he was making changes in this file but was unable to run this Turtlebot 3 DQ in stage 4. Meaning he was making changes and his goal was to create maps for this stage 4, not the simple Turtlebot 3 world, but it was not happening for him. Let's take a look. The first understanding I had for this problem was multiple Turtlebot 3 gazebo package existence. Let's understand what that is. For example, I am inside of Robotism workspace. Let me open up another terminal. I have 3 different workspaces: learners workspaces, Robotism workspaces, and ROS2 workspaces. Let me open all of these one by one. In all of these 3, I have this package Turtlebot 3 Gazebo in Robotism workspace, Turtlebot 3 Simulation and Turtlebot 3 Gazebo inside of it. Then in ROS2 workspace, Turtlebot 3 Simulation and Turtlebot 3 Gazebo. All of these 3 different workspaces are containing the same package name, which means if I call it, it is going to cause overlapping. It is going to cause confusion for us, not for the computer. So ROS2 package prefix Turtlebot 3 Gazebo. When I press enter at this specific point, it says package not found because it is not installed in the system. I have not installed Turtlebot 3 Gazebo with this command sudo apt get install ROS humble Turtlebot 3 Gazebo. That's why it is giving us an error. So I'll stop it and try to run this command again. It is not there. Now, as we have it inside of Robotism workspace, I will source the workspace. It has sourced the workspace, and now if I say ROS2 package prefix Turtlebot 3 Gazebo, I'm meaning find this package where it is. It says you can find it here. Now the most interesting thing is if I directly source my learner workspace install setup bash. Now we have the Robotism and learners workspace both sourced, but the order is first Robotism then learners. Now if I say find this package, it says this package Turtlebot 3 Gazebo is placed in learners workspace, and now it doesn't know that it is also placed in here. And again, if I do the same thing with the third workspace, ROS2 install setup bash. So what you can see easily here, the latest sourced workspace containing the package is going to be utilized. For example, currently it is able to find Turtlebot 3 Gazebo of this workspace, right? And I start to make changes in Robotism workspace. Let's say I make the change in the launch file of Turtlebot 3 world, where I say for the world file you are going to utilize DQ in stage 4. This is confusing because you have to understand it in your mind what is actually happening. I have made change in Turtlebot 3 of which workspace? Robotism, and I am currently finding Turtlebot 3 in ROS2 workspace. These are 2 different workspaces. At this specific point, I am in Robotism workspace. I will perform call can build, which saves all of the changes. Now let's source our Robotism workspace and find out the prefix. And this is the problem. Even after the sourcing, it is not setting up Turtlebot 3 from Robotism workspace. So at this specific point, let's source Robotism workspace and perform the ROS2 launch Turtlebot 3 and Turtlebot 3 simple world. This time with this world file, we are going to have the DQ in stage 4. Although I called the Turtlebot 3 world file. Now this is a lot confusing because of the multiple packages, but that's how you find out which specific location package it is using, in which workspace it is placed, and you change the files accordingly. The second issue is Moveit tutorial regarding robot description semantic parameter. Now the problem is robot description semantic parameter, which is a parameter. It comes up that I am unable to find this and I am unable to find the robot description as well. A lot of details are provided, but just look at this. Could not find parameter robot description semantic, did not receive the YSTD messages within 1 second. Let's try to reproduce this error. If I go into my VS Code, I have a workspace and a Moveit configuration done for my robot. Let's run the simulation. Now here you can see I have KUKA in RWiz with Moveit configuration and Gazebo as well. Now the thing is, to reproduce that error, we have to look into source file motion drive Moveit. What it does, it utilizes move group interface of Moveit, and it deals with KUKA ARM move group interface and sends this as a goal and then makes the robot move to a certain location. Now if at this specific point I run this node ROS2 run KUKA ARM package and this Moveit drive a node and press enter, let's take a look into our simulations. Our simulations are not moving, although we have sent the command through this node, which is Moveit drive. And here we can see a similar error, as we can see from this issue is showing that could not find robot description semantic and did not receive semantic via standard message, unable to parse SRDF and things like that. Exact copy of the problem. Now the thing is, if you want to make your Moveit configuration working with your nodes and services, you need to provide path to robot description semantic. And here if we take a look here in the fourth launch file that I have, first of all you provide all the paths to configuration files which are produced by Moveit configuration itself. So robot description path is this, robot description semantic is this, and trajectory execution controllers is this, and decompose it and put it into a dictionary and use it as a parameter. Now this specific node is running the same node motion drive Moveit, which is named as Moveit drive, but also utilizing this Moveit config node as parameters. So now let's try to run it. ROS2 launch KUKA ARM package for Moveit controller file. Let's press enter and see if it is moving a robot, and we can see to a specific location this node is making a robot move. As it says execution request success, let's take a look. The robot is at a perfect location which we sent was, if we take a look, 2 in X, 1.5 in Y, Z2. To look from the above exactly, 2 in X, 1.5 in Y, and along the Z it is 2 meters. So this is the basic understanding. To use move group interface for your robot, you need to provide parameters composed in the form of dictionary to the node of move group interface. When you are working with custom robots which contain 3D meshes, you are going to fall into some errors in URDF. For example, all of its joints are working perfectly. The joint 1 is good, joint 2 is good, joint 3 is not good. You can see it is going through the body. This is not the proper axis on which it should be rotating. In mobile robots, it's quite obvious the robot starts to rotate on the wrong axis. Other than that, all of the joints of this robot are working perfectly. So what is the catch in joint number 3? Let's take a look into its URDF. If we search for joint number 3, which is here, it is a revolute. The point of wrong axis is defined in this axis tag. Currently it is rotating along the Z axis. As we have observed, it is rotating along the top Z axis. Appropriate axis is Y for this specific example. Let's build it and run this simulation in RViz again. Add the robot. And let's test through the joint state publisher GUI. Now if I rotate, it is perfectly rotating around the required axis. So you can fix these axis problems using your URDF Axis tag inside of that specific joint. There is one more problem that happens a lot when you are using custom 3D meshes. Let's import our file in Blender and understand the problem of origins. A Collada file, ARM package URDF meshes visual link number 3. Now here we can see we have a link number 3. The problem comes at a point where I select all of these points and I translate it. Let's say I translate in the x-axis. I make it to this specific point, and now I select all of the points and export it as link 3 underscore. The problem happens now. Origin is at the origin, which is not yet enabled, but the body has been translated. Let's make the changes in the URDF link underscore 3 dot DAE. At that specific point, we are going to replace it with the new edited DAE file that we have produced. Colcan build and run this RViz simulation, adding the robot, and you can see the robot's body has been translated as well. So you have to be really careful for your body's 3D meshes to be exactly at origin. But still, if I rotate it, it is going to be rotating perfectly around the origin that we have produced on the 3D mesh, rotating at this specific point, which in the Blender we can see this is the origin. Now the problem happens when you mess up this origin, and a lot of your time gets wasted to fix all of these issues. You have to be really careful with the axis on which it is rotating and the origin of the 3D mesh file. Let's pause for a minute and understand that URDF macros or macros have a lot of importance in the world of robotics because they explain the robotic structure in simulations. URDF is a de facto standard in a lot of simulations, MATLAB, ROS2, Octave, NVIDIA IsaacSim. So you should be really good with it. This problem gives a lot of understanding how the joints are working, but you can even explore it by your own self for better understanding. The next issue is error loading custom robot manipulator model with Moveit2 and ROS2 Humble. Similar issue is execution plan, motion plan in Moveit2 is failing. Why that happens? Let's understand it. It is quite messy here, but as I have gone through it a lot, the problem lies in this line of what, according to loaded plugin description, the class Gazebo ROS2 control Gazebo with the base type hardware interface does not exist. This is the point where the whole error happens. Let's take a look on the second one, and it throws the same error. What, according to the loaded plugin description, class Gazebo ROS2 control base type does not exist and declare types are this. So it is having an error with ROS2 control Gazebo system. Let me give you an example. I have two Moveit packages. The first one is ROS2 launch KUKA ARM Moveit package. And let's run the demo.launch file for it. The demo.launch file is the auto-generated Moveit configuration launch file that tests all of the Moveit functionality into your robot. If I give this specific goal and plan and execute, the robot starts to move and it says goal request accepted and executed. Everything is working fine here. It is saying that solution was found and executed. So this package, which is KUKA ARM Moveit, is working fine. Let's go to another package, test control demo.launch. Same launch file, but the package is different. Let's open it up. RWiz has loaded. The robot is also loaded. If I give a goal to the robot's body and perform plan and execute, it is planning, but execution has failed. Let's take a look into its terminal output. This is the same terminal output that the guy has printed. Let's directly go to the error that was posted, and it is what, according to the loaded description of the class Gazebo ROS2 is there. It does not exist. Declare types are this. The problem is very simple, but because of this great big error, people get scared. And the problem is directly related to the URDF file. I have two different URDF files of the same robot. Let's analyze them. Everything inside of both of these URDFs are same, except just one line, which is this line number 21, which includes ROS2 controls, meaning our robot's ROS2 controllers are initialized in one URDF file but not on the other. So what happens when you have already initialized ROS2 control and you utilize this URDF in Moveit configuration? Moveit also added ROS2 control automatically. Moveit also includes the ROS2 generated by itself into the motion planning and all the structure of the robot, and it is already there. That causes the problem. The error that we can see was generated because of this, that Gazebo ROS2 control Gazebo system plugin does not exist. But for the other file that I created separately, which was named as KUKA KR210 Moveit URDF, controllers are not included into this file. That's why we are able to utilize it in Moveit, and that is how the package KUKA test control demo.launch utilizes this URDF, and the KUKA ARM Moveit, which was working, utilizes this URDF. And that's it for today's episode. If you have any questions, you can ask me on my social platforms regarding it and provide me a lot of details. Always keep in mind that solving problems requires patient and systematic approaches. And before posting on Robot Stack Exchange and ROS answers, you need to provide and explain all of your configuration, all of the files you are running, and then the great community of ROS will help you out.